Gentlemen, thank you for joining today's Technology Perspective webcast led by Danny Banks, Vice President of Solutions Engineering and Emerging Markets. Today's event is focused on the emerging state of security information and event management solutions and why specifically traditional solutions like RSA and Vision and others are just not able to meet customer needs. Before we begin, my name is Carrie Jacquet, and I want to remind everyone that we'll be hosting more of these Technology Perspective webcasts, so please keep an eye out for those. Now let me introduce Danny Banks. Danny has been with Sensage since early 2003 and has been involved in every customer deployment since. Danny has over 18 years of technical experience and holds a degree in physics at from the University of California at Davis. So he's not just good looking, he's really smart. So with that, Danny, I'm just going to start in by asking you what you think is causing the need for analyzing all this security event data that our SIEMs are storing. Like what's bringing this need on?
Yeah, so thanks, Carrie. So I think it's a great question. What I see happening in the marketplace is that organizations are really driving a bigger need for visibility. They want visibility into their data. They want to know what's going on within their environment. And that visibility is within the information that is this big data, this new data source, data types that's being generated within these infrastructures. And in order to get visibility, you need analytics, and really that's the driving factor these days. I would say many years ago, Sensage coined the term enterprise security analytics because we really saw that the visibility was going to come from doing correlation, historical reporting, forensic investigation against the data set, and that would drive knowledge, that would drive awareness, that would drive decisions, and drive value for our customers. And so I think that's, at the end of the day, what's driving it is just a whole new level of visibility that these organizations want to have.
And do you think, I mean, talking about sort of leading into the Verizon data breach report and what's causing us to say, yeah, you know what, the reality is that event data is important to point out things that are happening over time. So how would you describe sort of what we're seeing here?
Yeah, I think what we're seeing is that the market has evolved, right, from okay, let me know what's going on right now in real time, and so I can, and in theory, I have a SOC and I have a dashboard where, there's eyes on glass and I know exactly what's going on and I can see all these blips and alerts. That's one thing, but when it comes to the advanced persistent threat, the visibility that's required there is not what's happening in real time, but what's happened historically over time. And these sort of reports from Verizon are demonstrating and showing that a lot of these large enterprises and government organizations don't have that historical visibility, and they don't know what's going on within their environments. And it's taking them weeks, if not months, to discover what's going on. And again, that's really beyond just real-time correlation, and from a timing factor in terms of what really needs to be analyzed and what really needs to be, provide visibility and analytics applied against that data set.
That totally makes sense, and I think, as we look at sort of what real-time meant to people, and as we think about, okay, when you are initially compromised, that may take seconds or minutes to happen, but then as you look at how long the breach is forming and how long it takes to discovery, oftentimes, as Verizon points out, not even by the people who are the victims of the attack. It's clear that the logs are either not being collected, not being analyzed, not being understood, right? And so that's right. A really good point back to the whole notion of, the world has changed, the threat landscape has changed, and therefore the horizon of time that you need to look at has changed.
That's exactly right. Yep.
So as we think about real time, sort of how would you say, going to the next slide, how would you say you would describe the real-time reliance as it stands today, that point in time view?
Yeah, exactly. And I think kind of what this slide demonstrates, if you look at the visuals, that sure, there's certain things that you're going to see within the data set if they happen all at the same time and if multiple sensors detect that information, right? So if you see A, B, and C happen, then that's a pretty good signature, you know, and a good way to alert you of an actual event happening. Maybe there was some reconnaissance that happened, so you saw that, you know, the firewall had detected that there was an IP scan within your environment. So, you know, one source host tried to scan multiple IPs within your environment. And so you saw that within a window of time. Then the intrusion prevention system detected, okay, yep, you know, one of the systems that was just scanned, it detected that maybe there was a buffer overflow attack on one of the web servers or one of those servers, and that happened at the same point in time. And then within the same point in time, you saw that, you know, the web server itself, from an operating system standpoint or application standpoint, restarted because now, you know, that adversary, that attacker went in and made modifications and restarted that web server to deface that website or wherever it might be. And that's your typical real-time sensors, real-time events happening around the same time. But there's a whole level of visibility outside of those minutes or hours that exist today that a lot of organizations are not catching. They're not catching the reconnaissance that probably happened months in advance, and those zeros and ones outside the typical realm of a real-time correlation engine of hours or maybe weeks worth of data. And so that sort of historical correlation is just not happening today. And that's a whole other level of visibility that needs to be provided within these organizations that they're just not getting from these real-time correlation engines.
Yeah, and I think, yeah, looking at sort of the next data point, when people think about big data, you know, the question was, does your organization think about security data as part of a big data problem? And I would say if we were to think about this from maybe a year ago, these numbers might have looked wildly different. And yet now we're seeing a big group of folks saying, yep, we see security data collection and analysis as a big data problem and requirement in our organization. So I think that speaks to the ones and zeros problem that you were just talking about, right?
Exactly, and because what organizations are realizing is that the information is in the logs, and the information that they need to have is, again, going back to the APT example, is first, you know, how did this APT get within my environment? Okay, now that it got within my environment, how far did it go, right? What subnets did it reach out to? What applications did it touch? What authentication events happened within that same time frame? And that's a lot of data, but that's the big data problem that these organizations are facing when it comes to security is they want that visibility, and the only way to get that visibility is to look at all that data, all that big data that they're, in most cases, already collecting, but they still have this kind of, needle or head in the sand approach. They don't have that visibility to look up above that and now start to glean true knowledge and information from that data set.
Right. And I think, you know, as I think about the Enterprise Security Group and the research they did here, yeah, I believe that in the next year we'll see even more people jumping on this notion that, yep, it is, you know, security is no longer this thing I monitor and, you know, it's an out-of-the-box kind of solution that I throw in a stack of stuff to have, you know, work for me. It is an analysis, it's a collection, it's a storing, it's all correlation, all the things you talked about. So I'm willing to bet that we'll be seeing bigger numbers on this chart when we look at this again next year.
Exactly.
So
yeah.
Moving on, not to pick on one SIEM vendor or another, but just generally we see that there are traditional SIEM vendors who are not able to keep up with this big security data set of requirements. And we have specific experience with RSA and Vision, so we'll talk about that throughout the rest of this, but certainly most of these discussions apply to many of the vendors. So
right.
Let's talk about why customers may be looking for alternatives. I mean, we already know that the big security data is driving their needs, but what are some of the real challenges that they're facing?
Right.
So
go ahead.
Yeah, so sorry. No, I was just going to say, so the first one is, how important is thinking about the event type, specifically the event construct as you're thinking about how to build the database for them?
Exactly. Yeah. So I think this is really kind of the first challenge that customers who have gone with the Envision approach in particular have faced, in that they took an approach that said, let's look and build a system that can handle IP data. And so they literally called it an IP database, was their specialized database for storing large volumes of data. And I think that was it was a worthy assumption, if you will, in that most network traffic has an IP address in it, and so that's the way to index the data and store it and so on. But I think what we're seeing, right, is that missed the mark. It's because not all data has IP addresses in it. Data sets such as call detailed records, building access logs, and application logs in particular, might have usernames and application names, but they don't necessarily have IP addresses in them. It's application data, and we're seeing that that's one of the key data sources, within inside of infrastructures that need to be analyzed from a security standpoint. And so, unfortunately, the IP address is not the most common denominator. The timestamp is. And so I think it was a worthy approach to use that IP DB, but we're seeing now that it definitely has its weaknesses and it missed the mark.
And so give me an example of a situation where the IP address piece is almost, is either secondary or irrelevant when you're thinking about, let's say, correlating lots of different sources. You talk about video or other things that don't have timestamps. Give me a few examples if you could.
Yeah, so I'll use the call detail record example, right? And so if you're doing analysis against a data set from a security standpoint, and you're detecting events that, say, somebody logged into an environment or they called into a support call center, they can see the authentication events from a Windows server or Active Directory of when that authentication happened. But then now they need to correlate that user ID to the events from the call center. And so what was the phone number from that workstation to those called to from phone numbers to the called from phone numbers and so on. And that correlation happens at another level than IP address, right? Typically by time, typically by user ID, where that correlation takes place. And so again, that's where, just one example of where we've seen the timestamp be the primary index and the primary correlation point versus the IP address.
Got it. That was very helpful. Thank you. So next, let's talk about what happens when you start collecting all the data. So you are pretty happy you deployed the solution. A year later, you're kind of putting out, you're ingesting a lot of data. What is the challenge that customers face at that point when they're dealing with some of these more traditional solutions?
Yeah, so really, this is a common thing that we've heard from existing Envision customers who have switched over, are saying that they're always able to get data into Envision, but pretty quickly they were having challenges getting data out. And really that harkens back to just the architectural approach of having a design that was built for fast collection and then kind of impressive speeds and feeds. I think is kind of just the route that Envision decided to take there, where the data is collected, but it's actually not parsed at collection time. And so the only index that was applied against the data was just the IP address of where the data came from and then the source type. And so you really leave a lot of heavy lifting to your report time, to your query time. And that's where these organizations, have basically given up on the solution because they have the data there, but because all the heavy lifting is done for report time and now they have so much data, they really can't run reports. They really can't get data out anymore.
Got it. Yeah, that does sound like a challenge. So now let's talk about you've got a situation where you need to either go back and do forensics, look at some, a set of events that may have taken place leading up to a potential breach, or you're looking to be more proactive and think about historical context as a way to, create baselines of what's acceptable activity and what's not, both requiring sort of a look back in time view. What's the challenge people face when they try to do that?
Yeah, and so it kind of ties back into the last challenge in that because they don't parse the data until report time, until query time, imagine a report that you want to run against a year's worth of data, right? And you want to do baselining, you want to do analytics, you want to do statistical analysis against that data. But that's not done, that's not available until query time. And so really you're first having to parse all the data. So when you run that report, you have to parse all the data, then get that data available to you, and then now do your aggregates and summarizations against that data. And that's really a non-starter, right? When you're talking about a year's worth of data, it could be terabytes worth of data, trying to parse it and then query it. And that's what I mean by having the heavy lifting done at report time. That's a huge limitation where if the data is not parsed, not available, then you have to do that as well for every single time you run that report. And this is also an architectural challenge that not only Envision faces, but the likes of Splunk and other kind of Hadoop-based systems, is that those systems have the concept of getting data in very quickly, but when it comes to report time, the heavy lifting is left until report time, so the data is not parsed until report time. So every single time you run a report, you have to parse the data every single time you run a report. And that's just, it's just architecturally one way to do it, but we've seen for security investigations and analytics that need to be run very, very quickly. It's challenging when you have a lot of data and when you have that overhead of having to parse the data at report time that you have in an Envision or in a Splunk or in a Hadoop type of environment. They have other benefits, but from an ad hoc investigation standpoint, reporting standpoint, those are limitations that our customers are definitely telling us about.
Yep, and I think you bring up another point, which is really on executing queries in sort of the past. It's also important when you're dealing with some of these other, the more traditional SIEM tools, that you know what you're looking for, right? Because you don't have that sort of horsepower that you can apply to say, I'm going to just ask it to find all associated IP addresses from the last 2 years to see if they've popped up before. You almost have to know and pinpoint where you're going, or else you could be wasting a lot of time, right?
That's exactly right. Yeah, and it goes back to kind of the traditional kind of relational database architecture and design, is that you would really want to design your database and your star schema and your indexes based on your queries, right? Based on your reports. That's how you optimize those types of systems. But the nature of security is that it's very ad hoc, right? Like you just said, you don't know the question that you want to ask of the data, and the question that you want to ask on the data probably changes on a daily basis. And so therefore, having to have a system that you have to design it ahead of time, theoretically having that knowledge, or after the fact you have to query it every single time individually, or parse the data every single time you run a query, it really just doesn't scale and provide the efficiency that these organizations need.
Great, that's helpful. Yeah. So next, let's talk about another area where we seem to see a lot of challenges when folks come over looking for alternatives, and that's around correlation. So when we're thinking about single source, really, I've got a set of firewalls, I just want to look at that firewall activity, makes sense. What's happening now that's causing the need for more complex correlations, and how does that break down those systems?
Yeah, I would say, what's driving are two things. Definitely from a security and analytics standpoint, these organizations are looking for efficiency in how they can look at the data. And so, a typical, and this is a challenge within Envision, another Achilles, if you will, is that, because the data is indexed by source type and then IP, you can run a report that says, here's my firewall, denied attempts summary report against my Cisco ASA data, and then run a separate report that here's my firewall denied against, attempts against my checkpoint environment or against my Palo Alto, networks environment. Those are all separate reports because that's how the data is indexed and stored. Versus most organizations from a security and compliance standpoint want to run a firewall report that, that shows my data correlated across multiple source types, and that in one single report, I can see data from Checkpoint and Cisco and Juniper and Palo Alto in one single firewall report, right? The same thing can go for an IPS report. The same thing can go from an operating system report, right? I want to know about failed login attempts from Windows, from Unix, and Linux, all in the same report versus having to have multiple reports. And that's one of the additional challenges within Envision, for example, is that those are individual reports, and so there's just additional overhead and obviously time it takes to run those individual reports and view those individual reports from a security and compliance standpoint. That just makes it difficult for these organizations to get the visibility they really need.
Yeah, and I think you bring up a couple of great examples. Another one, which, they're so disparate, is, call center, sort of, IT trouble tickets correlated against firewall activities to see, if there's a spike in IT tickets and suddenly we know, some firewall issues occurred and that's blocking users. So, I mean, sometimes it's not even just a set of systems or applications or
Right.
users. You're correlating, apples and bananas, right? So
You got it. You got it. Exactly. I just gave the simple example, but you're exactly right. Right, cross source. So correlate data between my firewall, my IPS, my operating system, my database logs. Right. That's really the next step that is even more challenging, where some of these solutions, just simply fall short.
Right. And speaking of falling short, as we think about time stamping and the importance of time stamping when you're doing those correlations, let's say now we are talking about, 3 different firewalls and lots of endpoints, and we're relying on timestamps to create sort of that unified view of a point in time and analyze that. What is the challenge around how that's collected in traditional systems?
Yeah, and so this is really, again, another approach that was taken, I think, as a shortcut that, comes back to haunt you, and that because you're focused on inserting data and collecting it very, very quickly, solutions like Envision would use the timestamp of when the data was collected as the timestamp of record, which is really, when you think about it, that's not the timestamp of when the event happened. It's not a one-for-one. Sure, the event of when somebody logged in is the actual timestamp of when the event happened, versus that data might not be then collected and stored within Envision for seconds later, for minutes later, for hours later, depending on the log rotation of that application or that source device and when it actually ends up in Envision. There could be huge gaps in time. But if Envision is always using the time the data was collected, then you have a gap there, and that doesn't match up forensically. And so that's again, because of the nature of just collecting the data very quickly and then trying to timestamp and have that information, that was the shortcut that was taken. But from a pure forensic standpoint, the timestamp is when the event actually happened. That should be the system of record, and a timestamp of record that's stored within the system appropriately. And so that matches up. So therefore, when you're doing an investigation and you're using a SIEM solution, so okay, yep, here are the failed login attempts, and you can go back to that source device and see, the source Windows event log, that timestamp does actually match up to what the source device has as well, to what the data says in that SIEM solution. And so a key challenge that these customers have faced with those traditional solutions like an Envision.
And so let me just make sure I understand, because light just comes on. So you're saying that in the case where an organization is doing batch loads of their event data into the system of record, those records are essentially timestamped according to the batch time, as opposed to when they occurred. Is that right?
That's exactly right. Exactly right. Now, the timestamp is in the data, but remember, go back to, they don't parse the data until query time. So the timestamp is not being applied as the timestamp of record within their system. So that's exactly right. When you're doing batch loads, you're going to be off by minutes, if not hours, of actually when the real event happened on that system.
Wow. All right.
Yeah.
So yeah, I had to reiterate that for the other marketing girls who went to public school. But okay, so that's very helpful to go back to. So now we sort of set the context for what the challenges are, and I don't want to turn this into a big infomercial for our solution, but really to kind of focus in on the technologies that allow folks to get what they need out of a SIEM. So let's talk about sort of the big things, and then I really want to drill into the data warehousing piece of this, if we could. So let's go through.
Yeah, so the big thing is it's really, at the end of the day, where we started talking about, is that collecting security data is a big data problem, right? You're talking about capturing millions, if not billions, of records within some of these large enterprises and government organizations. But the main common denominator is that it's timestamp data. I say all the time is that when we talk about big data, and it's really the main data set that's driving big data, is timestamp data, is, call it log data, call it audit data, call it machine data, whatever you want to call it, but at the end of the day, it's event data, it's timestamp data. You have the time of when the event happened, and then some additional payload information about that event. And that's the data source that we're talking about. And so it is a big security data issue, and collecting that data, that is this timestamp data from any source, is one of the things that that is driving that. The other key is that now that you have the data, and again, where I started is it's about visibility, and it's about analytics, and it's about correlation, and it's about forensic searching against that data set. But it's about getting that information very, very rapidly and quickly. I mean, there's a lot of solutions out there that can do, batch processing and schedule of analysis and so on, and that's all good. But again, when it comes to this security use case and what customers are really looking for from an ad hoc standpoint and really wanting to know what's going on in their environment right now, they want rapid analysis. They want rapid investigations. We talk often about, our customer base in EMEA and large telcos that use our solution for call detailed record data retention and analysis. And one of the main factors that EU data retention law, has language that refers to these telcos being able to do analysis and find out, what phone numbers, made phone calls, or what phone numbers made phone calls to other phone numbers, and providing that analysis without undue delay, right, is kind of the terminology there, which is really, they want it within hours. They want somebody, if the case where somebody's looking over your shoulder, you need to provide results. You can't say, okay, I need to run this query and, come back after lunch, or I'm going to run this report and come back tomorrow. They want rapid analysis. And they want not only the real-time view, but they want the historical view as well. As we touched on, the challenge is that you might be able to hold a certain amount of big data for, maybe a week, maybe a couple months. With our most SIEM solutions are focused on maybe 90 days of storage. But there's so much value in a historical view in terms of behavior over time from network environments, based on machines, based on users, based on policy changes that have taken place over time, and how does that change vulnerabilities? How does that potentially change attack vectors that are now available within the environment? And so having that historical analysis capability and that retention is a huge factor as well in terms of just overall security intelligence and security visibility.
And I think we're seeing more and more of the discussions around anomaly detection and that sort of thing, and yet you can't really understand what an anomaly is unless you know sort of what your baseline behaviors are, right? And so I think that's an interesting point that is going to start becoming more and more painful for customers who have a traditional solution, trying to squeeze that to happen to get that historical context. Yep.
Indeed.
Okay. So did you cover all three of the points? Yeah, I guess in a way we did. So we should go right into the, the heart, the engine, the brain of our solution, and talk a little bit about that.
Yeah, so this is, my one-pager plug, if you will. So, in talking about the challenges that we just talked about and really looking at it from a big picture standpoint, at the end of the day, this big data needs to be collected, needs to be retained, and needs to be analyzed. You need quick visibility into that data set. And really that's the problem that Sage saw a long time ago in terms of putting together our technology and the innovation that we have over time, is that we knew that there was going to be a need for a new technology that could handle data that was going to be large volumes, large varieties from multiple sources, and retained for long time periods, that data set was coming about that would not be able to be handled in traditional data warehouse technologies, which at the end of the day, if you think about it now, that's kind of the educational definition of big data. And so what we've done is we've developed an event data warehouse solution when I say we've developed it, it's developed over 10, 11 years ago. But it's an event data warehouse solution that, number one, is a time-indexed system. And again, because now when you really think about the data set that we're talking about, it's timestamp data, it's event data, it's log data, machine data, it's timestamp data. And so the first thing that we do with our engine that gives us the efficiency and effectiveness of doing the analytics on this data is that we time index it. Number two is that it's a natively compressed data store. We realize that this is going to be large volumes of data and storage isn't cheap. And so the benefits of taking that data but yet storing it compressed is going to be huge for our customers in terms of total cost of ownership and how much storage they would need, and if they could use directly attached storage, or if they would have to use SAN storage. Having that data natively compressed is a huge factor, and we built that into the system as well. And then the final piece from a technology standpoint, and by the way, all of this is patented technology now. We got the patents granted in 2006, is that it's a columnar data warehouse. We realized that relational data stores were very effective and useful when it comes to storing, product SKUs and customer names and maybe thousands of records, maybe millions of records, but probably thousands of records. But columnar was going to be unique in dealing with large volumes of data, and the advantage of storing data on a columnar compressed nature was going to give us huge efficiencies, but then also being able to query data on a per column basis instead of having to pull out an entire row of information, only pulling out the columns that you need to satisfy an ad hoc query is very, very efficient. And so we've just seen huge performance benefits based off of that. And that's really, the key data point there. The other benefits and the way the system is designed is that it is a massively parallel processing engine, in that you can run our solution on a single server, you can run our solution on 5 servers, you can run our solution on 50 servers. It's designed to scale up, and that's really a benefit for our customers in that today they're probably only doing a certain amount of data, but data volumes are only growing, right? Like we're seeing with the big data issue, is that our customers are getting more customers, they're getting more employees, they're getting more partners, they're installing more servers and applications, and so the data volume is only growing. And so therefore having a solution like ours that can scale up and provide linear scalability over time, you simply add more nodes to an existing SimSage cluster, and that increases the overall performance in terms of load rates, in terms of processing rates, in terms of the analytics that we do appropriately. And the solution can be deployed on physical servers as well as within a virtual environment as well, if you have an ESX farm. The point that I just touched on when it comes to parallel processing is that we use the entire cluster. Again, if it's 5, 10, if it's 50, to do distributing data loading, so we get very, very fast insert rates because every single node within the cluster takes a piece of the data that's coming in and parses it and gets it loaded very, very quickly. And then at the same time, that same distributed nature and parallel processing is utilized when we query data out of the system. Every single node within the cluster looks at their slice of the data to help bring that result back, be it just a forensic search type of query or be an aggregate query. There's actually individual aggregation that happens on each individual node, and then that information is summarized back to the top and back to the console. I touched on the columnar storage, and really the columnar storage again, benefits us from a compression standpoint based on the cardinality of the data. If you have data set that we store within our system and you have things like user IDs and IP addresses, you're often going to see that the IP address could be the same value amongst millions of records. It's just the nature of the data. Or maybe the application name might be the same value across millions of records. Well, when we store that application name in its own individual column and then compress it, we'll get really good compression because it's really only one value across millions of records. And so the cardinality of the data comes into play, and for this type of data set, security data, we often see that there's common values within the data set. And so that's what allows us to get really good compression. On average, we get 10-to-1 compression, but we've often seen certain data types provide 40-to-1 compression based on, again, the similarities and the commonalities and the cardinality within that data set. The solution, we definitely do appreciate the need for real-time correlation and analysis, and so the Sensei solution absolutely provides real-time correlation, both threshold-based and scenario-based correlation of the data that comes in. But we also, as we've touched on, have the full forensic capability and all the raw log data parsed, readily available for forensic and historical correlation as well. And the benefit is that it's the best of both worlds. We have the real-time correlation. You can see alerts show up within our console, but then you can very quickly right-click on an IP address or a user ID and drill down into the historical data right away to say, okay, well, I saw this alert that this user had a bunch of failed login attempts. Now, you know what, let me check all the events for that user for the past 6 months. And that's simply a right-click action that drives back into the event data warehouse to show all the events, be it operating system event or whatever it might be, to provide that information for the customer and for the end user. And then finally, we've extended the platform in such a way that even though it's a purpose-built, patented technology for storing these large volumes of, this big security data, we've opened up the analytics with analytics libraries, and would also open access, something that we call our open access extension, allows our customers to use standard business intelligence tools, just BI tools, to do analytics and analysis and get visibility out of the data set that we store by just using standard SQL and using ODBC or JDBC as that transport layer. And so that really has opened us up and again, increased the overall visibilities that our customers are able to get from the huge volumes of data that we store by allowing that open access extension or by allowing that openness from an ODBC, JDBC standpoint to use, maybe existing tools that they already have in-house to provide that business intelligence, but provide now that security intelligence against the data set that we're storing. And so those are a couple key points there.
I wanted to just jump into this one point because the others I'm not smart enough to talk to. I told you guys he was smart, but the piece that I think is most interesting here is that every security organization is different, right? And there are layers of people who do different things. So you might have, the guy who's just looking at dashboards to identify any big areas that need to be addressed or investigated. Then you've got the investigator who's being given a case to go back and review. And then you've got the ad hoc guys who are very proactive and looking for patterns, looking for trends, looking for those anomalies, and they're doing sort of the big crunchy stuff. And I think this last point is really that we give visibility, back to that you had me at visibility of big security data, that every single person can digest the security data in a way that's meaningful to their work environment and to their task, right? Yeah.
Exactly. I think you're exactly right. Yeah.
Right. Okay, so let's just say I'm an existing traditional SIEM solution user, and I'm thinking about move. Now the move might be I want to talk about them in context of two types of moves. One move is I don't want to swap out my real time. I love my real time, and I just want to augment it with all of that historical richness that you're talking about and be able to drill back, et cetera. So I want, if you could, I would just like a couple minutes on that. And then if I were saying I want a full-on swap, let's talk about what that would look like. So can you address both of those sorts of moves?
Yeah, sure, absolutely. So yeah, the first scenario that you mentioned, I think is a good scenario because there are organizations that kind of have solutions in place and use cases for those solutions from a real-time standpoint. And so what Sensei can provide is our event data warehouse that is a system of record for storing all the detailed logs, the raw logs and parsed, and then have that information available for your long-term forensics and your analysis and your investigations. But what we can do is we can collect the data and then store all the data, but then go ahead and forward some of that data to a real-time correlation engine, a separate real-time correlation engine. And there's a couple things that happens there. One is that you have a system of record where the full logs are stored and parsed and available for forensics, but then also you're not basically killing that real-time correlation engine that you might have, because I'm sure there's been performance issues. With this approach, we are able to filter some of the records that get forwarded to that real-time correlation engine. So it actually makes it easier on them to do their job versus when they're trying to look at every single record, right? So maybe you filter and only forward failed logins, or you filter and only forward denied attempts against the firewall, or you filter and only forward proxy server events that are malware events, right? That's the type of filtering that we can do on the data. We'll have all that information stored, all the proxy events, but only forward the malware events to that real-time correlation engine, and therefore it makes it easier on them in terms of that sort of analysis. And so that's a move that customers have made already that we have, but then more customers, I think, can see some value out of that. In your second scenario, in terms of a move, just an all-out move, we've definitely seen in many cases, and again, really going back to Envision, where customers have said, that solution is just not working anymore. I can't get information out of it. And so we've worked with a number of customers, and we've learned a little bit more each time that we've done it. But basically, there are utilities, there are tools within Envision, for example, a tool called LS Data that allows you to pull out the data, the historical data from that system, and you can do it based on time range and log type, and that will actually pull out the raw logs from that system, and then you can turn around and then take those raw logs and send those into SenSage, and we can store them with our adapters and have them nicely parsed and stored. And that could be first against the historical data that they have, and so going back 6 months or a year, and just write a script that is little by little taking data out of that system and then getting that into SenSage, so you can have that historical context now readily available within SenSage. But then also, because we are primarily an agentless-based collection system, you can already start then forwarding your syslog sources, let's say, for example, to the SenSage IP address, right? Or maybe even bifurcate the data. So you might have both systems running at the same time for a little while, but to start forwarding logs to SenSage. That's a very little effort from a syslog standpoint. Or in the case for Windows servers, we have a very, very powerful what we call our Windows Retriever, which allows us to agentlessly collect Windows event data from Windows servers. And we can do that. We can pull those logs off those Windows servers, again, without modifying anything within the existing environment, and then still allow you to run both systems in parallel for a short period of time appropriately. And so those are some ideas in terms of a move. Again, when it comes to Envision in particular, we know the utilities to get the historical data, as well as start getting the real-time data, the actual events that are flowing through the network. And so that move we've done several times, and it's pretty straightforward.
And so again, I am the dim bulb on the tree here. If I have a bunch of systems, applications, et cetera, you mentioned, agentless. Are there pre-existing collectors, or how does that work? I mean, how would I know, okay, I collect from these 50 different things, I'm going to have to re-engineer all of my collection process? Yeah.
Exactly. No, it's a good point, because the answer is that's not the case that you have to re-engineer anything. The approach that SenSage has taken is that, number one, again, agentless, primarily agentless in terms of getting data. So it's very seamless in terms of putting sources to us, so the data is pushed to us, or we can pull the logs, pull the data from the devices by just giving us the authentication information or FTP or whatever it might be to pull the data. So there's no re-engineering that needs to happen there. But then once the data is collected, we then apply our what we call our log adapter technology, which is, for this data source, we know what the log format is, we know the schema for that data, we know what the fields are, and that's how we're going to store that information. And we have a library of over 250 log adapters, and so we're very familiar with the most common applications, the most common network devices, the most common firewalls, where we already understand that data. So there's no re-engineering that's necessary. Just point the data to us, or give us access to pull the data from those sources, and we'll apply our existing log adapters against that data set, and then right away we'll be able to provide customers with the visibility that they're looking for.
That's very great. Okay, so I'm ready to learn more. Where do I go? How do I? You had me.
So really the first part is send us a note at info@sensage.com, and we will provide a free assessment, which is really kind of looking at the customer's environment based on the discussion that we've had here. You know, what is the existing SIEM solution that they might have? Do they have Envision? Are they facing these sorts of problems? What sources are they collecting from? We can really walk through that and then provide a demonstration of the move that we just described in terms of letting customers know how we could work in coexistent with an existing kind of real-time engine, and how we can collect data but yet forward it to that engine and filter it, then forward it to that engine, or how we can do the full move in terms of here are the utilities to extract data out of those solutions, and then here's the direction to be able to agentlessly have data forwarded to us, or have us pull those event logs. And so we can go through that in a very quick, WebEx or online demonstration as necessary.
Perfect. That's awesome. So that totally helps. And as always, visiting www.sensage.com will give you a lot of other information about sort of the technology that Danny's talked about, lots of different assets you can download and review. And if you're just in research mode right now, that's the best place to start. If you're ready to take action, send us a note, and we will contact you immediately for that assessment and demo. So Danny, thank you so much. This was really, really, well, it was fun, and I learned a lot of things. And I hope that everybody else did too. So we'll look forward to another Technology Perspective webcast with you shortly. Thanks a lot.
Thanks, Carrie. Thanks, guys.